Okay, so turning to the discussion at hand, we have our FPD and our MAD. Now, from this, we can also infer that this is FD is going this way, negative, minus FK, and then positive f of t. This is equal to this should result to m x double prime. Now, when we rearrange these terms, we'll find out that this is actually equal to mx plus force of damping plus k, and this would be equal to f of t. Okay, so consequently this is our expression. Now we need to find a relationships for FD and FK. Now musturatory FD, force of damping, this is just equal to what from our basic physics. This is c times velocity. C is actually the coefficient of damping. Coefficient of damping or damping factor or whatever mga terms ni siya, that is our C from university physics. Now, when we talk about FK, that is our stiffness. That should be equal to K times X. Just like springs. Now, I would like to rearrange these terms here. Replace them with Cx, and this is Kx. Then is equal to f of t. This is the differential equation of motion of our SDOF system. Okay? So I hope you guys really brush through with your calculus and differential equations, since we will be dealing with lots and lots of differential equations. So hope makastudy mo Laplace transforms. There are many methods to evaluate this expression. We can utilize auxiliary equations with imaginary roots, nonlinear equations, and then also Laplace transform. I find Laplace transform to be my favorite. But let's try much more kato na mga basic lang sa mga kwan pamagi sa pagsolve ni siya. Okay? So I hope you brushed up on your calculus. So I'll just pause this and then to make room for the derivations. Okay, resuming. The equation of motion here states that mass times acceleration plus damping coefficient times velocity plus stiffness times displacement is equal to the forcing function or the seismic induced load. Okay. Now, there are many cases. There is a general treatment for this, but it is very cumbersome. So let's just try with the much more simplified case. Now, what we'll be talking about here is, let's try structures that are undamped. Of course, we're still not capable of discussing the more advanced terms, so let's just go for undamped, free vibration, undamped free vibes. Okay, so we're talking about undamped free vibes. The terms here, undamped. So you say, when it is undamped, our C is equal to 0. Of course, when we say free vibration, our forcing function is also equal to 0. So in that case, this consequently ends up being like this. This is equal to 0, this is equal to 0, and therefore Ako na siyang i-bring down and din eh. Rewriting this. It will just become is equal to 0. Okay? This is for undamped free vibes. Free vibration. Okay? So, if you have any questions, just comment them on the video or on the post. Okay? We will be dealing with this particular equation for this lesson. Okay? Now, I would like to erase this and make room. I'll just pause this video. Okay. So, for undamped free vibes, we have this expression here. Again, C is equal to 0, Ft is equal to 0. So this is this will just degenerate into this. Okay. Now, with this expression here, I would like to play with this equation. It becomes x double prime plus divide everything by m. So this is the result here. Now, further simplifying this, I would like to use there are plenty of ways on how to solve this. You have the Laplace transform, you have the auxiliary equations. I would like to use the auxiliary equations of imaginary roots. Okay? Dapat mo na diniso. Anyway, in its differential form, I could say that this Km is a constant, so it's not a very big issue. This is equal to 0. This is its differential form. Differential form. This is the differential form of our equation, and then its auxiliary equation counterpart, changing d to lambda is equal to k over m is equal to 0 rather. Solving for lambda, we will have a positive and negative result on Isayaha, but it is imaginary. It carries the imaginary number here. So this is actually equal to 0. It's equal to positive, negative times I. Okay? Further expanding this, I will find that this is equal to lambda is equal to 0 plus a negative square root k over m is I. Okay? We're basically playing with differential equations from here on out. Now, I would like to take this expression here, and I would like to solve this. Now, as we recall from ordinary differential equations, its solution should be of this form. If lambda is equal to a plus and minus bi, the corresponding solution to this would be equal to, from differential equations, okay, slight review from differential equations, we will have y is equal to a arbitrary constants, a cos rather, cos b of x plus b I sine bx. Okay? If you can recall that expression from ordinary differential equations. Now, ito siya awat-awat. Kini siya o gato. Diba? This case, a is equal to what? 0. This case, b is equal to square root of k over m. Okay? Now, if I were to try out analogy, this would easily come out as a cos square root of k over m, but this is a function of t. T is our indeterminate independent variable. So this is a bi sine, and this is a square root of k over m times t. This is our expression here. Now, a and b, these are actually arbitrary constants. So, mas tsara lang, pwede rin siya madula-dula dayon, ba? I'll just take this I. I is also a constant, although it's imaginary. Pwede mo na siya madula-dula diri. Can be absorbed na lang din yung B. Total, it is arbitrary, so meaning madula-dula ra nato na siya. Okay? Mathematics should be like that, na pwede ra dula-dulaon. Now, we will have this expression here. A model for our displacement sa our Sdof, our structure. Now, for convenience sake, nasa take ko nandan eh, natay ka nang i-observe isa ka special na parameter here. Now, this square root of k over m, aside from medyo convenient ni siya ikuan, in case nato siya sa isa ka term, which is w, I'll just call this as w or omega or ambot na sa ikuan la. Yeah, you can name it basically on whatever you want, but let's call this w. This is very special. Okay, this is a very special term. Now, as you can see, cosine and sines, those are actually trigonometric functions, meaning it is cyclic. Okay, so cyclic siya. Goes from one position to another, back and forth siya, just like the movements sa itong structure. It now makes sense na dayon that this expression for drift, or rather for the horizontal movement sa itong floor, should be cyclic because it goes back and forth, back and forth, back and forth. So, makita niyo why it is best modeled as trigonometric functions. Now, the thing is, with trigonometric functions, oscillate siya, mabalik siya sa yung current position, back and forth, back and forth. So therefore, nasa ka ng frequency niya, og nasa J period, ba? Okay. So, I would like to define W as our natural frequency sa itong structure. It is the, shall we say, the frequency. When you say frequency, kaya ang number of times na maka-oscillate ng due sa per unit of time. Now, when you talk about this, unsay ano niya, sir? Unsay unit ano niya? What is its unit? Now, K, we should take note that K is actually a function of force. Force over meter. Rather, let's take this lang sa units ano niya. Newton times Newton over meter. Now, Newton is actually equal to mass times gravity. So, when you say gravity na sa siya, this is actually equal to kilograms multiplied by acceleration squared. Now, when you talk about mass, that is kilograms, ba? So, this cancels out, kani siya mawala siya doon. Leaving us with just, na lang, 1 over squared. But we have to remember that all of this is encased within a radical sign. Now, kung radical sign siya diri, mawagi pa siya square root. Thus, our units will be 1 over s. When we talk about natural frequency sa structure, our units will be 1 over s, or short we can say hertz. Okay, muna siya yung unit. I know this is something not very wholly discussed ato sa civil engineering ba, personally sa ako ang encounter ng hertz last first na ako na-encounter na to sa physics. Now, comes kung nasa quietly evident na po din siya din when we talk about structural dynamics, hertz na po, magawas na po na siya din Okay? So, I hope this doesn't hurt sa inyo mag-study mo, okay? So, any questions, you can just comment them on the video or the post, and I will try to answer them to the best of my ability. Okay? I'll just cut this. Okay, so carry on where we left off sa itong break. So we have the expression for displacement as xt is equal to a cosine wt plus b sine wt. Okay, so diligay siya kuan nga ni karon. Now, this is, although the differential equation has been solved, but we still yet to evaluate what is a and b, the arbitrary constants in the expression. Now, so in a case, I would like to set some boundary initial conditions here. Now, when we talk about initial conditions, these are sa states lugar ang conditions sa atong structure before ni start ng paghapak sa atong load ba rather. Now, before the counting na began. So, when we talk about initial condition, that is the condition sa atong structure when time is equal to 0. Okay. This becomes quite interesting na rin because time will always start from 0. There is no negative time. Okay, so wala pa naka-invent ng time machine, so time is equal to 0. Now, if that is the case, we have initial displacements. Okay, so just call this as kini. When time is equal to 0, our x should be our initial displacement niya. Okay, initial position or initial displacement. Okay, so we have two arbitrary constants here. So therefore, we will need at least two conditions ana sa iya. We have the initial displacement here. Also, we should have the initial velocity. Can be 0 or unsa ba, as long as natin mga initial conditions ana sa iya para ma-define nato what is A and B. Now, this is initial velocity sa to ang ni floor. Now, if I were to place this ato siya i-consider sa itong mga equations here, but first we have to define what is velocity and acceleration. Now, if I were to differentiate this, I will have velocity. Okay, so I'll just change this to v is equal to the derivative of this, which is equal to negative a w derivative of cosine, that is sine, negative siya, but then we'll just carry it over, and the derivative of sine is equal to cosine. So sorry, so we have this expression here. I hope that it is still visible pa, although na-shine na nagamay sa light, but anyway, just try to clarify, and then later on we have velocity expression for velocity, and then I will differentiate this and I will have the acceleration niya, the acceleration function here. This is equal to derivative of sine is a positive cosine, so it's still, and this will be squared cosine wt, and this is b w squared sine wt. Okay, so we have something that looks like this. Okay, now applying the initial conditions to ang problem here, we can now solve for a and b. Now, a when x is equal to, when t is equal to 0 rather, our x0 is equal to xo, ba? So, x initial a, this is cosine 0 plus b sine 0. Okay, so we have the following expressions here. Now, when sine 0 is equal to 0, cosine 0 is equal to 1. So therefore, we can just say that our arbitrary constant here, a, is equal to this. Okay? So a is equal to the initial displacement sa ito ang structure. That constitutes as another formula. Now, I have v here. And I would like to play with this na sad. Now, playing with this, applying the initial conditions, I will have that v sa VO, rather, is equal to v sub O. So, this is v sub O is equal to A, where A is equal to, sige lang, sine 0 plus B, W, cosine 0, then siya, ba? Sine 0 is equal to sa 0. This is equal to sa 1. Okay, cosine 0 is equal to 1. Now, our A sa dendere, that is equal to sa XO. So, we have something like this na sad. We have VO is equal to negative XOW plus BW. Okay? So, okay, so slight clarification here. Since this is 0, this term essentially disappears and we are left with this lang. Well, so, I would like to play with this na dayon. V is equal to VO over W, our natural frequency. Now, I'll just box this in and we will have B is equal to kani and A is equal to kana. Gets? So, I'll just write this here. A is equal to XO. Then we move on to the last part of our derivation.